Hi, welcome to a LeetCode medium question. I just realized that I've been solving a lot of easy questions, and then the playlist for LeetCode medium is becoming really dry, so I want to update it. So let's solve this question. It's called 2-city scheduling, and it says a company is planning to interview 2 N people, given the array costs, where cost of I is equal to A cost of I, B cost of I. The cost of flying the ith person to city A is A cost of I, and the cost of flying the ith person to city B is B cost of I. So return the minimum cost to fly each person to a city such that exactly N people arrive in each city. So these prompts sometimes sound really intimidating, but they really aren't. So all you have to do is break down the problem. So what exactly does this problem want us to solve? Okay, so say for example, the company wants to interview 20 people, and they have 2 cities where they could potentially send those 20 people to. So they want to send 10 people to city A and then 10 people to city B. They want to send an equal amount of people to both cities, and then they want to do that in the most cost-effective way possible. So I can imagine an algorithm like this working at some big tech company wanting to interview a bunch of people. So when you have on-site interviews, maybe they have something like this that works for them, but that's just a hunch. So how do we solve this question? So first of all, let's break down the input that we're given. So we're given a 2D array where we have the cost to fly each person to either city A or city B. So I've put city A in green, and then I've put city B in yellow. So for, let's say, the ith person, the first number would be the cost to fly that ith person to city A, and then the second number in yellow would be the cost to fly that person to city B. So we're optimizing for costs, right? But this means that we have to use some sort of greedy algorithm to assign that person to go to the cheapest city. And we have to come up with some smart way to do that. So if there's a very cheap city at the end, we also want to get to that city. I hope this is going to help you understand the color coding that I did for city A and city B is going to help you as we go through the example. We're optimizing for cost. So how do we solve this question? So I just realized I forgot to put commas, so let me do that. So for the first person, we can either send that person to city A, pay $10, or send that person to city B, pay $20. Second person, we can send that person to city A, pay $30, and then send that person to city B, pay $200, and then send the third person to city A, $400, or city B, $50. So what we want to do is to sort this array in descending order of the differences to send each person to either city A or city B. So what we want is the most dramatic cost differences to be in front. So for example, if we want to do it in the most cost-effective way possible, we want 400 and 500. We want it to be in front so we can send the third person to city B instead of city A, because city B is cheaper to fly to instead of city B. So let's do that. Let's sort this input array in descending order of the differences in cost to fly from either city A or city B. Fly to either city A or city B. Cool. So when you sort the array in descending order of the cost to fly each person to either city A or city B, you'd get this as a result. And how did we get this? Because when we do the difference for the first person, 10, 20, difference is 10. And then here difference is 200 minus 30, that's 170. And here difference is 350. And then here the difference is 10. So if we sort this in descending order of the differences, we're going to have 350, 170, 350, 170, and then 10 and 10. So that's it. So now that we sorted the input array in descending order of the cost to fly each person to either city A or city B, we can now implement a greedy algorithm that would allow us to send each person to the cheapest city. So I'm going to write this as sorted so we don't forget. So sorted is this. And now let's implement the greedy algorithm to send each person to the cheapest city. So we're going to iterate through the sorted array and then apply that principle. All right, so we get to the first person, that's this guy, and then we check, is it cheaper to send this person to city A or city B? Now we realize that it's cheaper to send this person to city B because city B costs $50 and city A costs $400. So we send this person to CDB. So CDB has one person, and the cost for that is $50. And then we move on to the second person at index 1. And then we check, is it cheaper to send this person to CDA or CDB? For this, it's cheaper to send this person to CDA because CDA is cheaper. So CDA has one person, and that costs $30. And then we get to the third person. Which one's cheaper? CDB is cheaper. So CDB has another person, and that costs $20. And then we get to the final person, and then we check, is it cheaper to send this person to CDA or CDB? It's cheaper to send this person to CDA, so we send this person to CDA. So we have one person in CDA, and then that costs us $10. So now what we have to do is add 30, 10, 50, 20 to find the minimum cost to send every person to either CDA or CDB in the most cost-effective way possible. Now we have to take care of a few edge cases. In cases where we have more people in CDA than we have more people in CDB, and you're going to see this as we go through the code. The order in which we send people to either CDA or CDB is really important. And then if we exceed half the number of people in one city, we have no choice but to send the other half to the next remaining city. So say, for example, we've sent like 2 people to CDA already before we got to this part. We have no other option but to send the remaining people to CDB because we want to send exactly half the number of people to each city. So that's how you solve this question. What's the time and space complexity? Well, we're doing a sorting operation that's going to take O of n log n time. So time complexity is T is O of n log n. And then for space complexity, we're doing everything in place. We are only storing the cost to the maximum cost, and then the count of those, which is just O of 1 operations. So I think space complexity is O of 1. Correct me if I'm wrong, but yeah, it's O of 1. So let's dive right into the code for this question. Okay, so you want to get the minimum cost. So I'm going to say int sum. I'll set it to 0. That's going to hold the variable for the minimum cost. And then we want to send half the number of people to each city. So I'm going to say int number of people that we're going to send to each city is equal to cost.length divided by 2. That's the number of people we're going to send to each city. And then we want to know the number of people we've already sent to CDA or CDB. So int, let's just say count A is equal to 0 for now. And then we have another int, count B is also equal to 0 for now. So we're going to iterate through in a while loop. Let's say int index is equal to 0. So we're starting at the very first person. And then we want to say while count A is not equal to n, or count B is not equal to n, while we still have people to send to both cities, to either city, then let's send those people. So while count A is not equal to n, or count B is not equal to n, it means we still have people to send. All right, so this is the order in which we're going to send the people. So if count A is already equal to n, we have no other option but to send that person, the current person we're looking at this index, to CDB, because count A is already full. CDA is already full, so the only option is to send that person to CDB. So I'm just going to say int cost of A, so it would be easier to remember, is equal to cost of index and 0. I think CDA is the first city, so int cost of B is equal to costs of index and 1. All right, so if count A is equal to n, we have to send that person to CDB, so we do count B plus plus increment count B, and then we add the sum. We add the cost to send this person to CDB to the sum. So sum plus equal to cost of b. And then we do the same thing for CDB, for count b. So if count b is already equal to n, then we want to send that person to CDA. So now that we've done that, let's implement the actual greedy algorithm, and that's if cost of A is less than cost of B, we want to send that person to CDA. So if cost of A is less than cost of B, we want to send that person to CDA. So we do count A plus plus, and then we do sum plus equal to cost of A. And then we do the same thing for CDB. So else if CDB cost of B is less than cost of A, we send that person to CDB. So count B plus plus. And now we're pretty much done. We just have to increment the index. So we go check for the next person, the I plus 1 person. So we do index plus plus to go check for the next person. And then when this while loop breaks, we're going to have the total sum, the minimum sum, to send each person to either CDA or CDB. So what we have to do is return sum. Well, let's run this. And cool, it's accepted. I'm going to submit this. Wrong answer. Oh my god. Let me see what's happening. Oh wait, I forgot to sort the array in descending order of the differences. That's really bad and embarrassing. I think I talked about it in the illustration. So remember, so you have to sort the array in descending order of the differences, so let's do that. Say arrays.sort. I always make mistakes. We're sorting the costs array, and then we're going to use a lambda function. A, CDA, CDB, and then we want to sort this in descending order of the cost to send each person to CDA and CDB. So we want to get the absolute value of B1 minus B0, B0 minus B1, so cost of CD1, cost of CDA, and then cost of CDB, and then we subtract that from math.abs, absolute value of A0, that's for CDA minus A1. So that's it. All this function is doing is sorting the array in descending order of the differences to travel to either CD. So let's run this code again and submit. Hopefully this time it's successful. So yeah, there you have it. That's how you solve the 2CD scheduling problem. It's not as fast as I expected, but I think it's okay. And these kinds of questions are the questions that I really, really like for interviews, because they don't tell you how to invert a binary tree or silly stuff like that, right? These are things that you might actually have to do on the job. So there you have it. If you like this type of content, please subscribe and share this video around the community, smash the like button for the YouTube algorithm, and comment down below if you have something to say, and I'll see you in the next one. Bye-bye.